Okay, this is our pre-algebra math lesson for Friday, April 3rd. We're on 13.4 today. Yes, 13.4. And we're going to be comparing and making ratios for perimeter compared to sides of triangles. So if we have a triangle and we have a similar triangle that's just smaller, then we can say that we can write ratios. Sorry about the glare. We can write ratios and say that this side compared to this side will give us a corresponding ratio of this perimeter compared to this perimeter. So x is to y as the perimeter of shape 1 is to the perimeter of shape 2. And we can make a comparison there, and then we can figure some things out. So this is kind of vague as we open, so let's do some real world examples, and I think it'll make a little bit more sense. So let's look at example 1. It says the ratio of sides, the corresponding sides of two similar triangles are 16 and 12. So let's just pick a side and say that this one is 16 and 12. Okay, the perimeter of the first triangle is 55 inches. So the perimeter equals 55 inches. Now remember, perimeter goes all the way around. It wants to know, find the perimeter of the second one. So we want to find the perimeter of the second triangle. And we can't just add these up, right? So what we can do is that we can say 16 is to 12 as the first perimeter is to the second perimeter. So 16 is to 12 as 55 is to x. Okay, but before I do this math problem, I don't want to work with these numbers being so large, so I'm going to go ahead and reduce them down. I can see that both of these are divisible by 4, so 16 divided by 4 is 4, and 12 divided by 4 is 3. Okay, so there's two ways to go about this. Either you can solve for x, or you can cross multiply and then solve for x, and that's going to be the easiest way. So we're going to say 4 times x is 4x equals 3 times 55. 55 times 3 is 15. 16, 165. I'm going to divide both sides by 4. So x equals, I'm going to come up here and do my work, 165 divided by 4. Of course, you have a calculator. So there's 141 and 1/4 remaining. Okay, you might have, if you put it in your calculator, you get 41.25, and then we see that it was in inches. Okay, so that's the perimeter. So the perimeter of this one is 55, and the perimeter of this one is 41.25. Okay, so let's do another example. And we're going to apply this to something other than a triangle. So the next problem says the perimeters of two similar hexagons. So hex is 6. So I'm going to do 1, 2, 3, 4, 5, 6. This is okay. And then 1, 2, 3, 4, 5, 6. Oh, I made them the same size. I want one to be bigger. I want to be smaller. Okay, so we're going to say that they are similar hexagons, which means they're the same shape, just not the same size. And the two similar hexagons, the perimeters are 20 feet and 180 feet. So I'm going to say that this one has 20 feet for a perimeter, and this perimeter has 180 feet. Okay, and it says the smaller hexagon has one side of 2 feet. What is the side? Find the corresponding side of the larger hexagon. So we want to find what this side is. Okay? So we can do the same thing. We can say our question mark, which I'm going to use an X for, is to 2, as 180 is to 20. Well, I want to go ahead and reduce what I can. So I'm going to mark those zeros out, and then I'm going to say that, well, look, 18 divided by 2 is what? 9. So x over 2 equals 9. Okay, I can still put that over 1, cross multiply, x equals 18. And then there, I don't have to do anything else. So what is this? It's 18 what? Feet. Okay? So that side is 18 feet. All right. So now we're going to look at the ratio of areas of similar polygons. Okay? So let's look at example 3. It says the first two regular pentagons. Okay, so let me draw our pentagons. I always need to draw the shape because I'm a visual learner and I need to see it. So make sure you draw these shapes. So a pentagon is 1, 2, 3, 4, 5. And then let's do a bigger one. 1, 2, 3, 4, 5. So there's our two similar pentagons. The first has a side of 4 centimeters. And then the second has a side of 3 centimeters. So I'm going to say 4 centimeters and 3 centimeters. So it makes sense. This one needs to be bigger because it's the bigger shape. The second, you know what? We're using first and second. I'm just going to draw this one over here so when we read our problem it doesn't confuse us. Okay, 3 centimeters. Okay, the first of two regular pentagons has a side of 4 centimeters. The second has a side of 3 centimeters. What is the ratio of their areas? Okay, well, if we look up in the yellow box up above that, it says the ratio of the areas of similar polygons is equal to the ratio of the squares of the corresponding sides. Okay, so the ratio of the area, so area 1 is compared to area 2, is going to correspond, okay, to the sides squared. So side 1 squared over side 2 squared. Okay, so it says what is the ratio of their areas? Okay, so what I want to do is first take what I've got, which is the ratio of their sides, which is 4/3, and I want to say that the area, the ratio of their areas will equal the first side squared over the second side squared. Okay, so 4 times 4 is 16 and 3 times 3 is 9. Okay, so 16 ninths, right, is the ratio of their area, 16 to 9. Okay. Example 4. The first two similar polygons has a side of 3 and an area of 10. Now this time it doesn't tell us what kind of side, because poly means many sides, so we don't know exactly what shape we're dealing with, so I'm just going to leave this one up here because we're just looking at the one side. It says the first of two similar polygons has a side of 3 centimeters and an area, so now we're talking about the area, remember, not the perimeter, but the area of 10 centimeters squared. Okay, and then it says the corresponding side of the second is 5 centimeters. What is the area of the second one? So remember, when we talk about the area, we're saying the area of one over the area of the second will equal the first side squared over the second side squared. Okay, so what is the area of the first? 10. Do we know the area of the second? Nope. Equals side 1 squared over side 2 squared. Okay, we're just plugging it in. 3 times 3 is 9. 5 times 5 is 25. Okay, so now we're going to go ahead and cross multiply. Okay, so 9x equals 250. Divide both sides by 9. What's 250 divided by 9? We'll pop that into your calculator, and that tells us that this area, the second area, is 27.5 0.8 centimeters squared. Okay? All right, let's do example 4. Okay, example 4. The areas of two similar pentagons, okay, I'll lift my pentagons up there, are 400 and 100. So 400 millimeters squared and 100 millimeters squared. Okay, so let's erase these sides. And then it says I'm doing example 5, aren't I? Yes, okay. One side of the smaller pentagon, so smaller number, make sure you're paying attention to your number and not your shape size. One side of the smaller pentagon is 9 millimeters. What is the area of the, hold on. Okay, find the length of the similar side of the larger pentagon. So this is our x. This is what we're trying to find. So remember, if we said that the area of the first over the area of the second will equal the side squared over the second side squared. Okay? 9 times 9 is 81. Okay, so I want to do 81 there. And we can reduce this fraction, so I'm going to go ahead and reduce it down to 4 over 1 equals x squared over 81. Okay, then we're going to cross multiply, and 81 times 4 is 324. If you put that in your calculator, will equal x squared. Okay, so how do we get rid of the squared? We take the square root of both sides, okay? And the square root of 324, you can put it in your calculator, and you get 18 millimeters. So this side is 18 millimeters. Okay, well, good job. And let's look at your assignments for today. And be careful with the formula for perimeter and the formula for area. Go back and look at those if you need to. And I want you to do, let's do 1 through 30 odds. 1 through 30 odds.